In this video, we'll be talking about properties of the natural logarithm function. Now, let's make some sense out of this function. First of all, let's let f of x be the natural log of x. Then this can be written as y. Remember, you can take f of x out and put y in. So we have y equals ln x. Now we can write this logarithmic equation as an exponential equation using the rule that y equal log base b of x is the same as the base of my logarithm is the base of my exponential, and my log is my exponent, so this is the exponent, and then that is equal to the argument of my logarithm. So if we use this rule, then my base of my logarithm, since it's a natural logarithm, the base is e, and then raised to the y equals x. So when you're talking about a logarithmic function, that's the same as saying e raised to the y power equals x. Now we can graph this, but it's easier if we let y be the independent variable. So we'll set up an xy chart. When y is -1, you can see right above the ln button is e to a power. So I'm going to use that key. So I'll press Shift ln, and then I'm going to let -1 be my first exponent because I'm letting y be my independent variable. So I'm putting numbers in for y. So e to the -1 will give me about 0.37 for the x value. Now we know anything to the 0 power is 1. Let me go ahead and do that with the e, just to show you. E to the 0 power is 1. And then e to the first power will be about 2.718. But let me go ahead and show you all of that on, or as much as we can display on this calculator. We got 2.718281828 and so on. It doesn't repeat. It looks like it does, but e is a irrational number, just like pi. It never repeats and never terminates. So let's just put 2.7. Okay. All right, now if we wish to look at just a little graph of this. When x is about 0.37, y is -1. When x is 1, 0. And when x is about 2.7, y is 1. 2.7 would be about here. Y is 1. So my graph of my natural logarithm looks something like this. This is probably should be more curved. But it is an asymptote to the y-axis. So our domain is x values from 0 to infinity, and again, don't include the 0. The range, we can have any number for our y as our exponent, so that's going to be all real numbers. The function is continuous. And it is always increasing. And it is 1-to-1. Remember that the way we decide if it's 1-to-1 is we check to make sure that it is a function with the vertical line test, and then we check to see if it's 1-to-1 with the horizontal line test. So it is 1-to-1. And also the graph is concave down. If that is ever needed, you'll know that the graph is concave down. All right, now the properties of the natural logarithm function, we have 4. We know that the ln of 1 is 0. And if you want to think of this as an exponential, we're saying that e raised to the 0 power is 1. So e raised to the 0 power equals 1. So if this helps you remember that the natural log of 1 is 0, keep that in mind then. The natural log of a product is equal to the sum of the factors. So the ln of a times b is equal to the ln of a plus the ln of b. And remember, logarithms are exponents. So when we have two exponentials multiplied together, we always add their exponents. So that'll help you remember. If you want to remember x squared times x cubed, that's your two exponentials multiplied together. That's the same as x to the 2 plus 3, because we add those exponents. The third property is the ln of a quotient is equal to the difference of the numerator and denominator. And if you want to think of that as x to the third over x squared, there's your division of your exponentials. That's the same as x to the 3 minus 2, because you subtract those exponents. And then our last property is the ln of a to the n power is equal to n times the ln of a. In other words, we can bring this exponent out in front and write n times ln of a.